Hello and welcome to another video by the AM Academy. Today I want to take another look at the FreeScan UE7 by Shining3D. This handheld blue light laser scanner is part of their metrology line, meaning it is designed to produce very detailed measurements of the scanned parts with an extremely high accuracy. Now in the last videos, I've unboxed it, I've calibrated it, and then I had my focus mostly on scanning larger parts, such as this car tire, this front of a scooter out of plastic, or this front grille of an old VW car. But today I want to go the other way. I want to have a very high resolution and high detail scan of this part right here. It is made by conventional manufacturing techniques, and basically the application that we're talking about today is quality assurance. These are made by the hundreds of thousands. And I want to know, does this part fulfill my requirements? Is this good enough? Are the holes exactly where they need to be? Is the overall shape exactly what it needs to be? Is this weird bulge here the shape it needs to be? And for that, I want to use a 3D scanner. So I've got this little mounting plate, basically, that I put my part on top of. And if I wanted to scan, one of these parts from every batch made, this bracket helps me keep a reliable setup and a repeatable setup, because that will be the main priority. So I'm going to try scan this and hopefully get some good results. I'll overwrite my test folder because that's just what I always do. And in the previous videos for the big models, we always went with a medium detail resolution because that was totally fine. It was a big model. If the entire model is 1.5 meters long, I don't need to have my points that close together. It is important to keep in mind, once again, this is not accuracy. The accuracy of the scanner stays the same. What I determine here is the distance between points in the point cloud. And for a big model, 0.5 millimeters between the points is totally okay. For this one right now, I want to have a better quality. I'm going to set it to high detail, which gets it all the way up to 0.2 millimeters between the points. I could still step it up to 0.1 if my result isn't good enough for me. But keep in mind, the higher you go, the longer the processing times, the more data your file will have. So it'll be a bigger scan file. It'll be more complex. It'll take longer to process. Your computer needs to be more powerful. I'll keep it on high detail for the time being, click apply, and we can get right to scanning it. One last thing that I want to mention is with the laser scanners, you always need these markers, all these little dots that I have all over my rotating plate here, and of course the mounting as well. I don't have a single one on my part. They are all stationary on my mounting bracket and my rotating table, meaning that even if I scanned 100 of these per day, I would not waste a single marker because all the markers are entirely reusable this way. And that's just something to keep in mind. Keep the waste down, save some money that way. So I'm going to put this back onto my mounting bracket and get right to scanning. Using the start button at the back of the scanner, I'm just going to initiate the scan, hold it over the area. I can see my preview. I'll go into the software view so you can have a better look at that. And then I will simply click start. And yeah, you can already see how fast it picks up the entire model. Now the scanner, whenever it doesn't see enough of the marker points or I have a bad angle, it'll make a little bit of music that you might have heard already from a minute ago. Whenever I'm too far away from the model, it'll make the same music. For the distance indicator I have on the left-hand side of the screen, there are these little bars that turn green. If I get too close, that'll turn red. If I get too far away, they'll turn blue. So that's an indication. And on the back of the scanner, there's a similar LED light that'll also color code and tell me this way whether I'm too close or too far away. One safety measure that the scanner also has is that if it doesn't pick up any markers during scanning, like this, it'll turn off the laser lines. This is just a security precaution, so you cannot accidentally aim the scanner just into thin air and have the laser lines potentially damage someone else's eyesight that was nearby. This is now I believe it's a class 2. Yeah, it's a class 2M laser classification now, meaning that especially for people with glasses or contact lenses, this can potentially be harmful to their eyes. Make sure not to look straight into the laser lines, especially not if you do wear glasses or it is someone that does wear contacts or something of the like. It shouldn't be too much of a problem. The Class 2M is still very safe, and you can use it without a dedicated safety briefing, but, you know, why take the risk? So, I'm going to rotate my table once again, get a nice view from every direction, and then, yeah, I think this is, well, good enough for me. If I move it around a bit, it does look very good. If I zoom in, I have a very high quality on all of the holes, especially the spulge at the top really looks great. These holes here are perfect. I can see all of them. I can measure distances between them and all of this stuff. So I'm content. I will generate my point cloud from this. And then I'll still have to cut away most of the mounting bracket that I have. Well, now picked up as well. It's white. The scanner thought, okay, that's part of my model. I'm going to pick that up. I'm going to scan that as well. And it'll just take a couple of seconds for me to get rid of that after the fact. So I'm going to let this generate the point cloud. What it does here is it sorts out unnecessary noise from the model. So some of the spots that I picked up from the rotating table should already be eliminated during this step. It tries to verify where the points are in relation to one another, and it tries to already, you know, optimize my point cloud in this step. Afterwards, all I do still have to do is mesh the model into an actual surface. So right here, now we can see this, but as I said, my mounting bracket is still there. I don't want it to be. I'm going to use the cutting plane to get rid of it, and I'm going to use that using the markers that I had on it. Hold down Shift on my keyboard and select a number of markers on my mounting bracket like this. You need at least 3, but as you could see, I could just decide to use 4 as well. And now I want to look at the side because, as you can see, my mounting bracket has areas that are higher than the plate itself. And now I will move this up until it just cuts the bottom of my part, but make sure that I get rid of the bracket area. So that's too far, but this looks pretty good. I'm going to click apply, have a look at what it did now. And yeah, I think I'm actually quite happy with this. I can then, of course, still manually select areas such as this one and get rid of them as well. But yeah, I think overall, my model result is already extremely good. Last thing left, as I said, is mesh the model into a surface. Generally, I often leave the recommended parameters on for this step. I'm going to turn the filter down a bit and just click apply, let the software do its thing. And yeah, after that, I'm basically already done. All that's left is to export the file, save it as an STL or similar, and then open it in a software such as Verisurf to verify your measurements. So that's then a third-party software that is necessary for the next step, where you can compare this to the STL model of what the part is ideally supposed to look like, and then you can compare the measurements between this scan right here and the original STL file that it was created from. So I think, yeah, I'm quite happy with this. I'm going to press confirm. I'm going to save it as an STL and call this the, I don't know, what is it? It's the metal part. I'll just call it that. Save it as an STL, OBJ, and 3MF part just to be on the safe side. Never hurts. Just going to put that right on the desktop. I can then copy it to a USB stick or whatever and use it in a third-party comparison software, really letting me get into the nitty-gritty and into the details of whether this part right here has the holes where they're supposed to be. Right, that's all I have for you today. Thank you very much for watching. This was using the metrology part of the FreeScan UE7 instead of just scanning larger parts and really getting into the high quality and high accuracy part of the scanner. I hope you liked what you saw. If you do have any questions or comments, please leave them below the video. Click the subscribe button if you like this type of video, because we'll be doing more like it, both for 3D scanning and general 3D printing with different machines. So, once again, thanks very much for watching. I hope you have a great day, and I hope to see you next time.